Now, when we conduct a hypothesis test, our desire is always to end up with a correct conclusion. So if the null hypothesis is true, we want to conclude that it's true. If the null hypothesis is false, we want to conclude that it's false. But sometimes there is the possibility of making an error. And so I want to examine those possibilities by looking at this chart. So at the end of our test, we're going to make one of two conclusions. We're either going to reject the null hypothesis. In other words, we're going to conclude that the null hypothesis is false. So if the null hypothesis, if we conclude that that's false, then we will reject the null hypothesis. Or we will not reject the null hypothesis. If we do not reject the null hypothesis, then we're concluding that the null hypothesis is true. So we reject the null hypothesis if our evidence convinces us that the null hypothesis is false, and we will not reject the null hypothesis if we conclude that the null hypothesis is true. So we'll make one of two conclusions. Now, there's also reality. Either the null hypothesis is true or the null hypothesis is false. One of those two things is definitely true. Either the null hypothesis is true or the null hypothesis is false. And again, what am I talking about with the null hypothesis? It's some sort of a statement regarding a population. So again, here at the beginning, it's going to be a statement about a parameter. So if at the end of the test, if I reject the null hypothesis, but if the null hypothesis is actually true, then I've made an error. And that is called a type 1 error. So a type 1 error is rejecting the null hypothesis when the null hypothesis is actually true. You should make sure you know that. Now, second possibility, I could conclude and not reject the null hypothesis. If I do not reject the null hypothesis, I'm concluding that the null hypothesis is true. And if the reality is that the null hypothesis is true, then I've made a correct conclusion. So again, this is my desire. My desire is, if the null hypothesis is actually true, I want to conclude that it's true and not reject the null hypothesis. So this is my desire. But if the null hypothesis is true and I reject it, I conclude that it's false, then I've made an error, and that's called a type 1 error. Other possibility. Well, the null hypothesis could be false. If the null hypothesis is false and I reject the null hypothesis, then I've concluded that it's false. So I conclude that it's false. It actually is false. That is a correct conclusion. But it's also possible that the null hypothesis is false and I do not reject it. So I conclude that the null hypothesis is true when in fact the null hypothesis is false. That is an error, and that is a type 2 error. So there's two different types of errors that we could make. So again, you need to know the distinction between these two types of errors. So a type 1 error is rejecting the null hypothesis when in reality the null hypothesis is true. A type 2 error is not rejecting the null hypothesis when the null hypothesis is actually false. So we can kind of think of this in the same way that we think of like a criminal trial. So in a criminal trial, the null hypothesis is that the person is not guilty. We assume that the person's innocent, in other words, until the evidence that's presented convinces the judge or the jury that the person on trial is guilty. So the presumption is of innocence, that they're not guilty. The alternative is that they are guilty. So if this is our null hypothesis and this is our alternative hypothesis, think about a type 1 and a type 2 error. So if the null hypothesis is actually true, so the person's really not guilty, but at the end of the trial we reject the null hypothesis, we conclude that they're guilty when in fact they're not guilty. That is a type 1 error. So a type 1 error is like convicting an innocent person. We're convicting a person that's not guilty. That is the consequence of a type 1 error. Likewise, a type 2 error, well, in that case, we know that the null hypothesis is false, meaning that the person is really guilty. It's false that they're not guilty, so they're really guilty. We do not reject that. So they're really guilty, but we conclude they're not guilty. That's a type 2 error. So a type 2 error is like letting a guilty person off. So a type 1 error is like convicting an innocent person. A type 2 error is like letting a guilty person off. Both of those are bad conclusions. We don't want to make those kinds of errors. Now, of course, the other two possibilities is that the person really is not guilty and we find them not guilty. That would be a correct conclusion. And a correct conclusion would be that they really are guilty and we find them guilty. That would be what's going on right here. So again, type 1 error is equivalent to convicting an innocent person. Type 2 error is equivalent to letting a guilty person off. The trouble with these two errors is that they're not independent. If I make it harder to make a type 1 error, then I make it more likely to make a type 2 error, and vice versa. If I make it harder to make a type 2 error, then I make it more likely to make a type 1 error. So they're not independent. So that's sort of the difficulty. So to summarize what I just showed in my table, there are 4 possible outcomes from a hypothesis test. 1, we reject the null hypothesis when the alternative hypothesis is true. This decision would be correct. So we reject the null hypothesis. We're concluding the null hypothesis is not true when the alternative is actually true. In other words, the null hypothesis is false. That decision would be correct. 2, we do not reject the null hypothesis when the null hypothesis is true. This decision would be correct. 3, we reject the null hypothesis when the null hypothesis is true. This decision would be incorrect, and this is a type 1 error. We do not reject the null hypothesis when the alternative is true. So the alternative is true, but the null is false. This decision would be incorrect, and this is a type 2 error. So this is the results of what we saw in our previous page. So we have a definition. The level of significance, alpha, this alpha that we've been using for quite a while now, alpha is the probability of making a type 1 error. So this alpha that we've been using all along is this idea of a type 1 error, but we didn't have the knowledge at that time to be able to define what a type 1 error actually was. So the level of significance, alpha, is the probability of making a type 1 error. So we're going to use that as part of our test. Now, if I bring back in this page, so alpha is going to be this probability of making a type 1 error. So that means the probability of making a correct conclusion is going to be 1 minus alpha when the null hypothesis is true. So assuming that the null hypothesis is true, the probability of making a type 1 error is alpha. The probability of making a correct conclusion would be 1 minus alpha. Likewise, if we call the probability of making a type 2 error beta, then the probability of making a correct conclusion would be 1 minus beta. So if the null hypothesis is actually false, the probability of making a type 2 error is beta, and the probability of correctly concluding that it's false is 1 minus beta. And that 1 minus beta is called the power of the test, and again, alpha is called the level of significance. So alpha equals the level of significance, and we're going to be using that extensively. 1 minus beta is called the power of the test, which again is the probability of concluding that the null hypothesis is false when it really is false. That's the power of the test. We're not really going to use this much in our course, but we will be using the level of significance significantly. In fact, in the pictures that I drew earlier, so when I'm doing a left-tailed test, alpha is going to be this area in the left tail. When I'm doing a right-tailed test, alpha is going to be this area in the right tail. And when I'm doing a two-tailed test, alpha will be the total area in the two tails. So this area will be alpha divided by 2, and this area will also be alpha divided by 2. Otherwise, the logic, the statistical and mathematical logic of conducting these hypothesis tests is going to be very, very similar to the mathematical and statistical logic that we saw in the previous chapter when we were doing confidence intervals. Hypothesis tests are very much related to confidence intervals that we saw in the previous chapter. So let's conclude this video with an example. Example. Historically, at Rick's Pizza, the time to make and serve a pizza has been 36 minutes. Rick implements a new system with the intent to lower this time. A. Determine the null and alternative hypothesis. B. Would this be a left-tailed, a right-tailed, or two-tailed test? C. What would it mean to make a type 1 error? D. What would it mean to make a type 2 error? So we need to come up with a null and alternative hypothesis. So remember that a null hypothesis is that a parameter equals a particular value, and an alternative hypothesis is then that the parameter either is less than, greater than, or not equal to that value. So the first thing we have to think about for part A is what kind of a parameter are we looking at when we're talking about this particular scenario. Well, historically at Rick's Pizza, the time to make and serve a pizza has been 36 minutes. So that's talking about an average. On average, it takes 36 minutes to make and serve a pizza, and Rick is wanting to lower that time. So he's wanting to get the pizza to the customers faster. So anyway, the parameter that we're talking about here is a population mean, mu. So historically, mu has equaled 36 minutes. So there's our null hypothesis. Again, that's my null hypothesis because historically that's been what is true. Now our alternative hypothesis is going to have the same parameter and the same value. So we're still going to have 36 minutes in the alternative hypothesis. The only thing that's going to be different between the null and the alternative hypothesis is that instead of equals, in the alternative we're going to have less than, greater than, or not equal to. So we have to determine which of those do we have for this particular scenario. Well, in this case, Rick's intent is to lower this time. So we want to lower the time to be less than 36 minutes. So that's going to make this less than. So that's the answer to part A. Our null hypothesis is that mu equals 36 minutes. The alternative hypothesis is that the mean is less than 36 minutes. Now, B. Will this be a left-tailed, a right-tailed, or a two-tailed test? Well, we tell that directly from the alternative hypothesis. Because the alternative hypothesis is that mu is less than 36, that makes this a left-tailed test. So what are we going to do now? We're going to gather data. So we would collect a sample of times that it takes to make and serve the pizza, and we're going to find the average, and we're going to compare that to the 36 minutes to see if we can conclude that it's still 36 minutes or that it's now less than 36 minutes. That's basically the deal. In other words, under Rick's new system, if we conclude that it's still 36 minutes, then that means the new system didn't work. It still takes 36 minutes to get the pizza made and served. But if we conclude the alternative is true, we're concluding that the new system worked. It now takes less than 36 minutes to make and serve the pizza. That's the idea of this hypothesis test. Now, question C. What would it mean to make a type 1 error? Well, let's do that up here. So remember that a type 1 error is rejecting the null hypothesis when in reality the null hypothesis is true. So if we reject the null hypothesis, we're going to conclude that the alternative's true. We're going to conclude that it now takes less than 36 minutes to make and serve a pizza. But if it's a type 1 error, that means we rejected it wrongly, that we're concluding that it takes less than 36 minutes, but the reality is this null hypothesis is still true. It still takes 36 minutes. So what would it mean to make a type 1 error? So that would mean that Rick concludes that it now takes less than 36 minutes to make and serve a pizza when in reality it still takes 36 minutes. So again, a type 1 error is the error of concluding that the new system worked when it really didn't. So Rick thinks that the new system's working, that he's now serving pizzas in less than 36 minutes, but in reality it's still taking 36 minutes. That would be a type 1 error. What would it mean to make a type 2 error? Now, making a type 2 error means we do not reject the null hypothesis when the null hypothesis is actually false. So we're going to conclude this is still true when in fact this is now true. So our conclusion would be Rick concludes that it still takes 36 minutes to make and serve a pizza. So we're concluding that it's still 36 minutes here, when in reality it now takes less than 36 minutes. So again, type 1 error, we're concluding that this is true when in reality this is still true. A type 2 error, we're concluding that this is true when in fact this is true. So a type 1 error again is rejecting the null hypothesis when the null hypothesis is actually still true, and the type 2 error is not rejecting the null hypothesis when the null hypothesis is false. And so in the context of our problem, this is the meaning of the type 1 and type 2 error.